So now we will continue with this question. We'll try to differentiate. This is a polynomial thing. So we're going to differentiate this together. So we have to find the y dx, right? The y dx. Differentiating this now, having 4 times 3 x raised to power 4 minus 1 plus 3 times 2 x raised to power 3 minus 1 minus 5 times 2 x raised to power 2 minus 1. Remember my minus sign, minus, there's a power here 1. 1 times 6 x raised to power 1 minus 1 plus, if you differentiate a constant term, it's always what? 0. Right? So I'm having 4 times 3 is what? 12. X raised to power 4 minus 1 is what? 3. Plus 3 times 3 is what? 6. X raised to power 3 minus 1 is what? 2. Minus 5 times 2 is what? 10. X raised to power 2 minus 1 is what? 1. Minus 1 times 6 is what? 6. X raised to power 1 minus 1 is what? 0. There's no need to write this plus 0 again, right? So I'm having 12x cubed plus 6x squared minus 10 x raised to power 1 is what? X minus 6. X raised to power 0 is what? 1. Right? So I'm having 12x cubed plus 6x squared minus 10x minus 6. So this is my dy dx. Right? So this is my final answer. Let's have another question on differentiation of polynomial terms now. If you have a question like this, we have y equals to 4x raised to power 3 plus 2x raised to power minus 2 plus 3x. Now, we're asked to find the y dx. 4x raised to power 3 plus 2x raised to power minus 2 plus 3x. Find the y dx. The same method now. dy dx. Right? So I'm having 4 times 3 x raised to power 3 minus 1 plus 2 times minus 2, right? X raised to power minus 2 minus 1 plus, now if I don't set the power here, what do I put? 1. So I'm having 3 times 1 x raised to power 1 minus 1, right? 4 times 3 is what? 12. X raised to power, what's 3 minus 1? 2 plus 2 times minus 2 is what? Minus 4. X raised to power minus 2 minus 1 minus 3 plus 3 times 1 is what? 3. X raised to power 1 minus 1 0. 4 times 3 12. 3 minus 1 2. 2 times minus 2 minus 4. You have to be careful. So you put it inside bracket. Plus, so now I'm having 12x squared plus times minus what? Minus. I have to be careful with my signs. Plus times minus what? Minus. Minus 4x raised to power minus 3 plus 3 x raised to power 0 is what? 1. Right? So I'm having 12x squared minus 4x raised to power minus 3 plus 3. Right? Now remember, I'm having a negative power of x here. And my final answer must not have a negative power of x. So what was I do? I'll further simplify. This is what? 12x squared minus 4x raised to power 3 plus 3. How did I get 4 over x raised to power 3? Recall, if you have a raised to power minus b, using our laws of indices, a raised to power minus b is like say 1 over a raised to power b. Right? If you have 2 raised to power minus 2, the same as say 1 over 2 raised to power 2. Or if I have 3 raised to power minus 3, the same as say 1 over 3 raised to power 3. If you have 4 raised to power minus 2, the same as say 1 over 4 raised to power 2. This is, so that's 1 over that number raised to power is the power. That number raised to power what is given. So that's what I did here. 12x squared minus 4 times 1 over, if I have 4x raised to power minus 3. So that's 4 times x raised to power minus 3, right? That's 4 times 1 over x cubed. That's 4x cube. That's what I have here. So it's okay. So this is my final answer. So if you differentiate this with respect to this, you'll be obtaining this. Now, to give us some tricky question to further solidify our knowledge on differentiation with respect to any variable. So that's what we'll be moving on into now. Now, if you have a question like this, now I'm moving to technical question. If you have a question like this, y equals to 4x cubed plus 3x squared minus 2x. I will have to find dy dt. Find dy dt now. In this question, t is not given in the question, right? So we have to include what? T, right? So imagine y to be equal to what? 4x cubed plus 3x squared minus 2x. Everything times what? T raised to the power 0. Remember, this dot makes times, right? Now I know that t raised to the power 0 is what? 1, right? And anytime I differentiate a constant term, it will give me what? 1. Automatically. Oh, it will give me what? 0 rather. Anytime I differentiate a constant term, it will give me what? 0. Automatically, if I'm differentiating the whole of this with respect to t, that means my dy dt, this will give me what? 0. Because of this idea that the differential, the derivative coefficient of a constant term is 0. Now you see the fundamental. Because 3 raised to the power 0 is what? 1. And if I'm finding the derivative coefficient of a constant term, it will always be what? 0. So that's why I got here to be what? 0. So now let me show you. If you doubt, now let me show you. So I'm having this 4x cubed plus 3x squared minus 2x times 3 raised to the power 0, right? Okay. Let's say I don't know this rule at all. Let's say I don't know. Let's say it eluded my mind. So now open the bracket. So I'm having 4x cubed 3 raised to the power 0, right? Plus this multiply this 3x squared 3 raised to the power 0 minus 2x 3 raised to the power 0. I use this to multiply this 4x cubed 3 raised to the power 0 plus 3x squared 3 raised to the power 0 minus 2x 3 raised to the power 0, right? So now I'm finding dy dt. That means I am differentiating y with respect to what? T. I'm giving respect to t in the question. So anything I'm doing is always with t. I don't have any concern with any other thing aside from t. So I'm having now dy dt. This is what? 0 times 4x cubed, right? T raised to the power 0 minus 1 plus 3x squared times 0, right? T raised to the power 0 minus 1 minus 2x times 0, T raised to the power 0 minus 1. Recall if I say 0 times 4x cubed, it's the same thing as saying 4x cubed times 0, it's still the same thing. So now 0 times 4x cubed is what? 0. 0 times the whole of this is what? 0 plus 3x cubed times 0 is what? 0. 0 times the whole of this is 0 minus 1, 0. At the end of the day, what's my final answer? 0. Can you see? So the derivative coefficient of a constant term remains what? 0. In as much as I'm differentiating a constant term, my derivative, my dy dx is always what? 0. But now I'm differentiating with respect to t, so that my dy dt is what? 0. So that's how I obtained 0 here. Now I hope this is clear. Now let's solve another question. If you have this kind of question in the exam, if you have y equals to 4x cubed plus 2x squared minus 3x plus 4 all over t. Now I have to find dy dt. Dy dt. Find dy dt. I have 4x cubed plus 2x squared minus 3x plus 4 all over t. I'm asked to find dy dt. That is differentiate y with respect to what? T. Right? Now this can be written as this. This function can be written as 4x cubed plus 2x squared minus 3x plus 4 into t raised to power what? Minus 1. The whole of this is same thing as this. Recall that 1 over t is the same thing as what? T raised to power minus 1, right? 1 over a is same thing as what? A raised to power minus 1. 1 over b is same thing as what? B raised to power minus 1, right? 1 over c is same thing as what? C raised to power minus 1. This is equivalent to this is the same thing, right? So this over this is same thing as what? The whole of this t raised to power minus 1, right? Now, knowing this fully, I can do two things. Either I open the bracket, that is, I expand, or I just differentiate it directly. I can do it two ways. Either I just open my bracket, then differentiate my final result, or I differentiate it as 0 like this. So it depends on you. So now I'll show you the two ways what I'm saying now. So now, if you have this, I'm looking for dy dt. Let me differentiate. Let me open my bracket first. So I'm having 4x cubed times t raised to power minus 1. So I'm having 4x cubed t raised to power minus 1 plus 2x squared t raised to power minus 1 minus 3x t raised to power minus 1 plus 4t raised to power minus 1. Right? I use this to multiply this. 4x cubed t raised to power minus 1 plus 2x squared t raised to power minus 1 minus 3x t raised to power minus 1 plus 4t raised to power minus 1. Now I'm differentiating this now. I'm having minus 1 to multiply this. That's what? Minus 1 times 4x cubed, right? T raised to power what? Minus 1 minus 1 plus minus 1 times 2x squared, right? T raised to power what? Minus 1 minus 1 minus, remember you have to be careful to minus sign, minus 1 times 3x t raised to power what? Minus 1 minus 1 plus minus 1 times 4 t raised to power what? Minus 1 minus 1. We are saying our rule, this times this, that's what I'm doing. This times this, then I subtract 1 from power. This times this, then I subtract 1 from power. This times this, then I subtract 1 from power. This times this, then I subtract 1 from the power. So I'm having dy dt minus 1 times 4x cubed. 4x cubed became what? Minus 4x cubed. Then t raised to power minus 1 minus 1 is what? Minus 2. The same sign, add up and put the common sign before the result. Minus 1 minus 1 minus 2, they are the same sign, so I add up, then I put the common sign, which is minus before the result. Then plus minus 1 times 2x squared, that's what? Minus 2x squared. Minus 1 times 2x squared, that's what? Minus 2x squared. T raised to power what? Minus 2. Right? Minus 1 minus 1 minus 2. Minus, I have to be careful. Minus 1 times 3 is what? Minus 3x. T raised to power what? Minus 2. Plus minus 1 times 4 is what? Minus 4. T raised to power what? Minus 1 minus 1 minus 2. The reason why I put this inside enclosed bracket so that I don't want to make mistake. You understand? So now I don't want to make mistake. That's why I kept this inside parentheses. So now I'm having minus 4x cubed t raised to power minus 2 plus times minus minus 2x squared t raised to power minus 2 minus times minus plus 3x t raised to power minus 2 minus 4t raised to power minus 2. Now this is what I just did. Minus 4x cubed t raised to power minus 2 plus times minus 2x squared t raised to power minus 2 minus times minus plus 3x t raised to power minus 2 plus times minus minus 4t raised to power minus 2. Can you see? Now remember, recall I told you that your answer cannot be, your variable cannot have negative powers. So you simplify them. So I can write this as what? Minus 4x cubed all over what? T squared. How did I get this? Recall. T raised to power minus 2 is same as saying 1 over t squared. Recall the rule that a raised to power minus b is 1 over a raised to power b. So t raised to power minus is 1 over t raised to power 2. This is done to remove the negative symbol that we're having here. If I have q raised to power minus 2, that's what? 1 over q raised to power 2. So that's why I'm having minus 4x cubed over t squared. That is, if I have minus 4x cubed t raised to power minus 2. So I'm having minus 4x cubed times 1 over t raised to power of 2. And I know that minus 4x cubed times 1 is what? Minus 4x cubed over what? T raised to power 2. That's how I got here, right? Minus 2x squared, the same principle applies. 2x squared t squared plus 3x over t squared minus 4 over what? T squared. I use the same method here. If I have 2x squared, 2x squared minus 2, the same as saying 2x squared times 1 over t squared. So that's 2x squared over t squared. Right? That's what I have here. The same thing applies for here. The same thing applies for here. That will be minus over t squared. So this can be written as my final answer. I can leave this as my final answer. Now the second method, which I said we can also apply. The second method, so you have to choose one. Now, you have this question. You want to differentiate it directly without expanding. Look at what you do. So you're having y equals to 4x cubed plus 2x squared minus 3x plus 4 t raised to power minus 1. Now let's find the y dt. The y dt. That means I'm differentiating this function with respect to t only. So now I'll use this. That means I'm only differentiating t. So I'll use this. Remember the principle. The power will multiply the coefficient. So the whole of this is taken as our coefficient. So I'm having minus 1 times 4x cubed plus 2x squared minus 3x plus 4. Right? The whole of this is taken as my coefficient. So this power will multiply all of this. So minus 1 times the whole of this then. So it's power what? Minus 1 minus 1. Remember the principle. You subtract 1 from that power of the variable that you are differentiating. First of all, step 1, you use the power of the variable to multiply the coefficient of that variable. So I'm having minus 1, which is the power, to multiply the coefficient of the variable I'm differentiating. And the variable which I'm differentiating is what? T. So I'm having minus 1 times the whole of this, which is here. Then I subtract 1 from the power of the variable which I'm differentiating. The power of the variable which I'm differentiating, the variable I'm differentiating is what? T. And the power is what? 1. Minus 1, right? Then I subtract 1, I'm having minus 1, minus 1, right? So I'm having dy dt now. Minus 1 times 4x cubed, minus 4x cubed. So this minus 1 will multiply each of them. Minus 1 times 2x squared, that's minus 2x squared. Minus 1 times 3x, that's what? Plus 3x, you have to be careful. Minus times minus, plus 1 times 3x. Minus 1 times 4, that's what? Minus 4. Right? T raised to power what? Minus 2. Minus 1 is what? Minus 2. Remember the same sign, add up, I put the common sign before the result. So I'm having minus 1 that's what? Minus 2. Right? Remember, I cannot have my variable having a negative power. So I further simplify. So this can be written as what? Minus 4x cubed minus 2x squared plus 3x minus 4 all over t squared. You see, if you have 2x plus 4 into t raised to power minus 2, it's like saying 2x plus 4 all over t squared. Remember, t raised to power minus 2 is what? 1 over t squared. So this is the same thing. So I just bring this under t squared. This is the same thing as this. But I don't want my variable to have negative power. That's why I got it like this. Right? So now, you might be wondering, why is it not the same thing with this? Why am I not getting the same thing with this? Now, if you break this down, that is, if you simplify this further, you'll be having, or that means you are simplifying it as this minus this plus this, then this. Now you see, at the end of the day, I still get the same answer. So I just simplified. I pick it this over this, this over this, this over this, this over this. They are the same thing. It's just like now, if you have, why did I say this? Look at now. If you have 1 over 2 plus, okay, let's say 1 over 3 plus 2 over 3. It's the same thing as saying 1 plus 2 over 3. Right? If you have 1 over 3 plus 2 over 3, it's the same thing as saying 1 plus 2 over 3. This is the same principle applied. So this is the same thing as this. So automatically this is also the same thing as this. I can also get this from here. If I bring everything together, then divide by t squared to give you the same thing. So it's the same answer, so there's no need for confusion. Now we'll be moving to product rule. Okay, let's go to higher derivatives first before we move to product rule. Higher derivatives, then after higher derivatives we move to product rule. Higher derivative. Higher derivative. Higher derivatives. Now, imagine those, let's have this scenario. We are asked to find dy dx, right? You've gotten your dy dx. They now ask you to differentiate it again. That is, find the second derivative of your answer. That's the meaning of higher derivative. That means you are increasing the numbers of time you are differentiating that variable. So now, if I have dy dx, right? And I'm differentiating this again. That means I'm having the dy dx. That is, I'm differentiating this again. First of all, I first obtain dy dx, right? Then I'm being asked to differentiate it again. That means the dy dx. So this is the same as saying d times that's what d squared y dx squared. Right? Now that if I wonder I got this, look at it. We have dy dx. You are now asked to differentiate it again. That is what you are defining dy dx twice. This can be written as dy times dy is what? Dy all squared, right? The x times x is what? The x all squared. So we write it as d squared y dx all squared. So this is the same thing as this. So we write it as the 2y dx squared. That's like the 2y dx squared. Let's say I'm asked to differentiate it again. That means I'm finding the third derivative. This is the second derivative. This is the first derivative, y dx. Second derivative. Now let's get the third derivative now. Our first derivative, dy dx, right? Our second derivative, that we're having dy dx times dy dx. So that's dy all squared over dx all squared, which is in a normal mathematical form, we write it as the 2y over x squared. Right? Now let's first get third derivative. Third derivative. That means you're having dy dx times your second derivative. Right? That means you're differentiating your second term again. The first differentiated, when it's differentiated the first time, that's your first derivative. If you not differentiate it the second time, that's your second derivative. If you not differentiate it the third time, that's your third derivative. You can continue differentiating it. So now, this is what? The 3y, the x cube. The 3y dx cube. D times d cube, then y, then the x times x squared was s cube. So the 3y, the x cube. D squared times this what? D cube, that is d squared times d. Since they have the same base, right? D, I write it out. The power here is what? 1. So I'm having 2 plus 1. That's what? D raised to 3. That's how I got this d raised to 3 here. Then my y. Remember, this thing is the same as saying dy always power 3. The same form. This is how we write it in calculus. So the x squared, so I'm having x times x squared, the same rule. There's a power here, 1. I'll write the common base x, the sum of the power 1 plus 2, that's what x raised power is 3. That's what I obtained here. I hope that's clear. So now we'll be solving question using this. Imagine imagine them give you a question, okay, if y equals to this, find the 2y dx squared. That means you want to differentiate it twice. That's the meaning. Or they say find the 3y dx cube. That means you want to differentiate it 3 times. So now, if you have y to be equals to 4x cubed, then now have to find the 2y dx squared. The 2y dx squared. That means they want us to differentiate this twice, 2 times. So first time, we first differentiate it. That means we first get the y dx, right? If we are differentiating this, we got 3 times 4. X squared power what? 3 minus 1. 3 times 4 is what? 12. X squared power what? 3 minus 1? 2. So this is my dy dx. This is my first derivative. But the question did not say I should get dy dx. The question said I should get the 2y dx squared. That means I'll differentiate this again. The 2y dx squared. That's what? 12 times 2. X squared power 2 minus 1. 12 times 2 is what? 24. X. This. So this is my final result. Can you see? The y dx just differentiate it twice. The 2y dx squared differentiate it twice. The 3y dx differentiate it 3 times. The 4y dx raised power 4 differentiate it 4 times. Like that. The ends, that's okay. So now this being said, I hope it's clear. So now let's move to another question. Imagine you have a question like this. We have these are monomial terms. So let's go to polynomial terms. Now we have 4x cubed plus 2x squared minus 3x plus 4. Find the 3y dx cubed. That means they want us to differentiate how many times? 3 times. Power of 3, that means differentiate it 3 times. That means the first differentiating, the answer I get to differentiate again for the second time. The answer I get to differentiate again for the third time. So now I'm differentiating this. First of all, first get the y dx. Differentiating this is what? 4 times 3, x squared power 3 minus 1 plus 2 times 2, x squared power 2 minus 1. Now minus, I have to be careful, minus, remember the power here is what? 1. Minus what? 3 times 1, right? X squared power 1 minus 1 plus, if you differentiate a constant term is what? 0, right? Right? So now I'm having what's 4 times 3? 12. X squared power 3 minus 1 is what? 2 plus 2 times 3 is what? 4. X squared power 2 minus 1 is what? 1 minus 3 times 1 is what? 3. X squared power 1 minus 1 is what? 0, right? That's what? 12x squared plus 4. X squared power 1 is what? X minus 3. X squared power 0 is what? 1. So I'm having 12x squared plus 4x minus 3. This is my dy dx. Now, as we are advancing, I won't be showing you all this again. I'll just go straight to the point. So it's important to understand the basic, because this I'm stressing myself like this. As we're advancing, I can just differentiate it immediately. I expect you to practice more questions, so you'll be familiar with the principle. Calculus is actually very easy. Once you put your mind to it and understand the basics, it's very, very easy. So now, I'm having 12x squared plus 4x minus 3. If you notice, if you differentiate the constant term, 0. Can you see? We made use of this key. If you now differentiate a variable with power of 1, the second key to give us our coefficient, which is minus 3. You see that if I wanted to solve it fast, I will not show you this process. I'll just apply my key, get my answer, rather than start showing you. But because we are still learning, so it's important to understand the basics. So I want us to digest this variable. If you differentiate a variable with power of 1 to give you the coefficient of that variable, that's minus 3, which I have here. If I now differentiate a constant term, a term that does not have any variable, it will give me what? 0, as you can see. So now this is my dy dx. The question does not say I should get dy dx. The question says that I should get the 3y dx cubed. That means I should differentiate it what? 3 times. I've got my dy dx. What will I get now? The 2y dx squared. That means the second derivative now. So I'm having the 2y dx squared. Differentiating this is what? 12 times 2, right? X squared power 2 minus 1 plus, normally I know that the answer is 4. Why did I say 4? Because this is a variable. I'm differentiating this variable. What is the power of variable? 1. And remember my key. Anytime you are differentiating a variable with power of 1, it's always what? The coefficient. But let's still go through the process. This is 1. So I'm having 4 times 1. X squared power 1 minus 1 minus, if you differentiate a constant term, that's what? 0. So I'm having 12 times 2 is what? 24. X squared power 2 minus 1, 1. Plus 4 times 1 is what? 4. X squared power 1 minus 1 is what? 0. Right? So I'm having 24. X squared power 1 is what? X plus 4. X squared power 0 is what? 1. So I'm having 24x plus 4. Now this is not my final answer. They said the 2y dx squared. this is the second derivative, but the question says I should get what? The 3y dx cube. That is the third derivative now. So I'm having my d3y dx cube now will be what? If I differentiate 24x, now I'm differentiating 24x, so my power here is what? 1. So I'm having 24 times 1, x is power 1 minus 1, plus, if you differentiate a constant, derivative of a constant is what? 0. Normally, I know that if I differentiate this is 24, because why? X, I'm differentiating with respect to x, and the power of my x is what? 1. And anytime the power of the variable you are differentiating is 1, it's always the coefficient. Can you see? So now I'm having 24 times 1, 24. X is power. What's 1 minus 1? 0. So I'm having 24 into what? 1. That's what? 24. So the 3y dx cube is what? 24. So my final answer is 24. This very easy, very simple. Once you understand the basic, it's very easy. So let's take another question. Last question that I have derivative. Let's take another question. So now if I have y equals to 4x cubed plus 2x squared minus 6x minus 5x raised power minus 3 plus 6. Find the 2y dx squared. The 2y dx squared. Now in this question, how many times do you want us to differentiate? How many times? 2. The 2y dx squared. That means you want us to differentiate twice, 2 times. So now, first of all, first get my dy dx, right? I'll differentiate it the first time. Differentiating this the first time, I'm having 4, this multiply the coefficient, I'm having 3 times 4, right? X is power what? 3, I subtract 1 from the power, plus, this times this again, 2 times 2, right? X is power what? 2 minus 1, minus, now I have to be careful, my power here is 1. Remember, if you differentiate a variable with power of 1, it's always the what? Coefficient, and the coefficient is what? Minus 6. I can just write it down, but let's follow the process fast, still early. So I'm having 1 times 6, x is power what? 1 minus 1. Same thing here. I have to be careful. Minus 3 times 5. X is power what? Minus 3 minus 1. And if I differentiate the constant, it's what? 0. Right? Remember, the derivative coefficient of the constant term is always 0. Now, I have minus 3 times 5, minus 3 minus 1. Remember my minus, I brought it out here. So anytime you say minus 1, you have to be very careful so you won't make mistake. So now I'm having 3 times 4 is what? 12. X is power 3 minus 1 is what? 2. Plus 2 times 2 is what? 4. X is power 2 minus 1 is what? 1. Minus 1 times 6 is what? 6. X is power 1 minus 1 is what? 0. Minus, I brought it out. I have to be careful now. Minus my bracket. Minus 3 times 5 is what? Minus 15. X is power minus 3 minus 1 minus 4. Right? I don't need to write it to 0 again. So this is 12x squared plus 4x. X is power 1 is what? X, right? Minus 6. X is power 0 is what? 1. Minus times minus plus 15x is power minus 4. 12x squared plus 4x minus 6 plus 15x is power minus 4. Now, I'm not stopping here. I'm getting the 2y dx squared. That means I'll differentiate it again for the second time. That's the 2y dx squared. So differentiating this again, I'm having 12 times 2, x is power 2 minus 1, plus 4 times 1, x is power 1 minus 1. If I differentiate the constant term is what? 0 minus 0, plus 15 times, or 4 times minus 15, right? X is power what? Minus 4 minus 1. If I not put the minus 15 here, I'll bring it outside here. It's still the same thing. 2 times 12 is equal to 2 minus 1. There's a power here, 1, right? 1 times 4, x power 1 minus 1. If I differentiate a constant term, this is what? 0. If I differentiate this, minus 4 times 15. Minus 4 times 15. Okay, let's put like this, minus 4 times 15. X is power minus 4 minus 1, right? 12 times 2 is what? 24. X is power 2 minus 1, 1. Plus 4 times 1 is what? 4. X is power 1 minus 1, 0. Minus 0. Plus Minus 4 times 15 is what? Minus 4 times 5, 20, that's minus 60. Right? X raised to power what? Minus 4 minus 1, minus 5. Right? So I'm having 24. X raised to power 1 is what? X plus 4. X raised to power 0 is what? 1 minus 0. Plus times minus, minus 60. X raised to power what? Minus 5. Right? So I'm having 24x plus 4. I don't try this, so that's minus 60x raised to power what? Minus 5. Right? Now, my final answer is having a negative power. And what did I say when you have a negative power? You further evaluate, you further simplify it in order to eliminate that negative power. So I'm having 24x plus 4 minus 60 over what? X raised to power 5. So this is my final answer. So that means that, look at how did I get this? I'm having minus 60 x raised to power minus 5. And recall, a raised to power minus b is what? 1 over a raised to power b. So x raised to power minus 5 is what? 1 over x raised to power 5. So that's minus 60 times 1 over x raised to power 5. Minus 60 times 1 minus 60 over what? X raised to power 5. That's what I have here. So this is the same thing as this. But I just don't want my final answer to have a negative power. That's why I further simplify. I hope this is clear. So now we'll be moving to product rule. There are some rules we need to know in calculus. So we're moving to product rule. Product rule. Product rule. Product rule. Now, if y is a function of x, right, and x is the product of u and v, what do I mean? If y is a function of x and x is the product of u and v, y is a function of x and x is the product of u and v. If I have y to be this, and this my x is same as what? U times v. So I can write this as u of x times v of what? X. Because my x is same as u times v. So if you have a question in this case, what do? You make use of your product rule if you are asked to what? Differentiate. If you have any question in this one, you make use of your product rule to differentiate. So now, my dy dx now, I'm differentiating this using product rule. That's what? V du dx plus u dv dx. So this is what the product rule is all about. So I'll be adding it to my bullet points. Product rule. Dy dx equals to what? V du dx plus u dv dx. So in the next video, I'll be explaining product rule, quotient rule, chain rule. Please like, share, subscribe, and also comment. Thank you.